Hello again. So today's lesson is going to be pretty short. It's just kind of a wrap up using the stuff that you've learned about linear relations, function notation, domain and range to actually answer some word problems. Okay? So we'll do a couple of those and that'll be it for today. So in the first case, it says Sarah's having a birthday party. She's reserved a party room for $30 and she has to pay in addition $10 per person for food. And it says the maximum number of people that she can have, including herself, is 16. So what we've got here is a table of values, and that table of values tells you the total cost for different numbers of people at the party. Okay? And so remember, even if nobody comes, even if she's the only one there, she still has to pay that $30 to rent the place and then $10 for herself. Okay? So, in other words, we can write an equation that says the total cost is equal to how much it costs to rent the place, $30, plus $10 for every person. Okay? So, if we had 4 people, it would be $30 to rent the place plus 10 times 4, or 40. 30 plus 40 gives you the number you see here. So it would cost $70 if 4 people came. Now if 8 people came, it would be $30 plus 10 times 8, or 80, for a grand total of $110. Well, what about 12 people? Well, that would be $30 plus 10 times 12, or 120, for a grand total of $150. And finally, for 16, it would be $30 plus $160, or $190. Okay? So, by substituting different values for n into your equation, you can find the value of C, the total cost. Okay? So, let's just run through this. It says, complete the table of values. Yay, we did that. B, are the data discrete or continuous? Now, I've marked a couple of the modules that have been handed in so far, the assignment booklets. And this difference between discrete and continuous seems to be confusing some of you. Okay? But generally, data are continuous when they can be broken down or subdivided. So things like measurements are always continuous. Okay, so for instance, if we're measuring a distance, or we're measuring a time, or we're measuring a weight, anything that can be measured can have fractional values, in between values. Whereas things like people, things that are not divisible, you can't have a half a person without a lot of blood spilled. Okay? So because one of our variables, our variable n, is number of people, we would say the data are discrete. Explain, you can't have partial people. Okay? So again, just ask yourself, is either of my variables something that you could reasonably be expected to divide into smaller bits, into fractional bits? And generally, if it's objects, it's always discrete. So whether those objects are people, or coins, or days stayed at a resort or something like that. All of those things can't be broken up into smaller bits. Identify the independent variable. Remember, the independent variable is always your x variable. Another way of thinking about it is it's always going to be the left column. If you're given a table of values, it's always going to be the left column. If you're given an equation, like this one up here, it's always going to be the variable on the right side of your equation. Okay, so you generally will isolate your dependent variable and your independent variable will be on the other side. Okay? Another way of thinking about it is the dependent variable is the variable that depends on the independent variable. So in other words, the total cost depends on the number of people. Okay? The more people, the greater the cost. Graph the relation on the grid provided. So we're going to do this very quickly because again, there were actually a number of you who seemed to struggle with the graphing, and I think a lot of it just had to do with remembering all the rules for graphing. Okay, so just let me very quickly copy down this table of values so that I can see it when we make our graph. So we had 70 and 30 and 0, 4, 8, 12, 16. Okay. So here's our lovely graph. Remember, when you're building a graph, when you're making a graph, you need to give it a title. It doesn't have to be cost of a party. You could say cost of a party versus number of people. That would be fine too, but give it some kind of a title. Then you have to label your two axes. Remember, the x-axis is the horizontal one, the y-axis is the vertical one. So our x values are always on the left side. So our x values, the independent variable, will simply be number of people. That leaves our y, or dependent variable, as cost. And where appropriate, please always put the units in brackets. In this case, it's dollars. Okay? Now we have to give our axes an appropriate scale. Okay? So for number of people, we're roughly going from 0 to 20. And if we count very quickly, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's not quite enough, so we're going to go up by 2s. Okay? So 0 people, 2, 4, 6, 8, 10, 12, 14, 16, 18. We're not going to go any further because our maximum is 16 people. Okay? And then for cost, we're basically going from 0 to 200. And we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Good, that works. So $0, $20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. You don't have to label every single grid line, okay? Whatever is simplest. I probably shouldn't have labeled every one of these because it got a little messy. No big deal. Okay, and then you plot your points. Now remember, each of these forms an ordered pair. So the first one is 0 and 30, the next one is 4 and 70, and so on. So we'll just plot those really quickly. The first one is 0 on the x, 30 on the y, so it comes in right here. The next one is 4 on the x, 70 on the y, and so on. I'm just going to very quickly plot these. 8 and 110, 12 and 150, and 16 and 190. So 16 and 190. And get your friend Mr. Ruler. Now is the point where you decide, do I have a continuous relation where there are in-betweens, or do I have a discrete relation where there are not in-betweens? And if you think about it, there's no possible way we could have a point, say, right here, because that would be the equivalent of about 1.5 people, and that would be like the birthday party massacre, okay? You can't have in-between values, okay? You could have 2 people, that would be fine, okay? But you can't have anything in between 2 people and 1 person, that would be messy. So, since this is a discrete relation, we don't join the points. Remember that. If you have a discrete relation where you have objects as one of your things, you can't, just give me a second, you can't join the points. Okay? So there's our lovely graph. Is this a linear or nonlinear relation, and how do you know? Well, we know that it's linear for a couple of different reasons, the most obvious being it forms a straight line. So you get a straight line out of it, it's got to be linear. But remember from the first lesson that I posted, another way you can check if you have the equation is by looking at the degree. The degree of this equation equals 1, right? There's no variables that have an exponent other than exponent 1, so we know that this, for that reason as well, is linear. Okay? Let's keep on going. State the domain and range of this relation. Now, this is another place where it seems some of you are having difficulty, so we're going to state the domain and range using set builder notation. Okay? So remember, our domain, we were told you can have as few as 0 people, but the maximum number of people you can have is 16. So that means our domain, start with squiggly brackets, and we can say n because n is our variable, but you could also just put x. We'll put x to make it a little less confusing. So x values, then you have a vertical line, and then you ask yourself, what values does x fall between? Well, x can be as low as 0 or as high as 16, so just write that. As low as 0, as high as 16, you know that x has to be between those two numbers, greater than or equal to 0, less than or equal to 16. And then the last thing you say is, what number set does x belong to? Well, we know that 0 is included, so it's not natural numbers, but we can't have any in-between values. So, and we can't have negative values, right? You can't have a negative number of people. So the smallest set that x would belong to is the set of whole numbers. Okay? Any questions about that? I forgot you're not standing in front of me. Well, hopefully you don't have any questions about that. For the range, remembering that the range is your dependent variable or your y variable, it would be y such that, that's what that vertical line means, and then we look at our values for y. Well, you have a minimum of 30 bucks. Even if nobody shows up, you're going to be charged 30 bucks. So that's our smallest value. Our biggest value, if the maximum number of people show up, is $190. Y is between those two values, greater than or equal to 30, less than or equal to 190. Now, for money, in this particular situation, you can't really have in-between values for money either, right? So, what we're going to say is y is an element. In this case, the smallest number set would be the natural numbers because there's no possibility that y could equal 0. Okay? Any questions about that? I did it again. We'll do one more. Okay, we'll do number 3. And then that'll be it for today's lesson. And it says, Northland School Outdoor Club had a fundraiser to help purchase snowshoes. The club had 300 power bars to sell. Okay? This graph shows the profit made from selling power bars. P represents the profit, and N represents the number of power bars sold. First question, by the way, here's the equation that describes that, and I'm just going to write it nice and big so that everybody can see it. P at N equals 0.8 N minus 40. Okay? In other words, your profit is calculated as 80 cents per bar sold minus $40. Okay? So, are the data discrete or continuous? Explain. Well, that's fairly easy because you have a line to look at. And this line tells you, remember what I said in the last one. If you have a solid line, you have a continuous relation. Because that means at least, well, you have a continuous relation. I would say this should be a dotted line because you're selling chocolate bars. You couldn't conceivably sell a half a chocolate bar or a piece of a chocolate bar. So I would say, even though you have a solid line there, the data are discrete as you can't sell partial chocolate bars. And I would say that whoever made this question should be slapped on the wrist. Identify the independent variable. Remember, the independent variable is always your x. Okay? So if you have a graph, it's easy. The independent variable is number of chocolate bars. Is the relation a function? Well, again, if you have a graph, it's easy because you can just apply that vertical line test. And remember, if a vertical line only crosses once, then it is a function. Okay, so we can say, yep. Explain why. It passes the vertical line test. State how many bars would need to be sold to break even or to have a profit of $0. Now there's a couple of different ways you can do this. If you have an equation, they're telling you your profit is $0, you could plug in $0 for your value and figure out how many chocolate bars you would have to sell. Okay? So we could do that, or we could just take the lazy way out, knowing that profit is our y variable. If the profit is 0, how many chocolate bars do we have to sell? Well, it looks like this goes up by 50s. So this point right here is 50 and 0, right? 50 chocolate bars, $0 profit. Now we can take very quickly, we can sub that into that equation just to prove that it works. So we'll do that. We're going to sub in a value of $0 for our profit. And we're going to solve for n. Okay? So, remember, to isolate this variable n means we have to get rid of this minus 40 and get rid of this 0.8. Always do adding and subtracting first, so we'll add 40 to both sides. That'll give us 40 equals 0.80n. This cancels, right? Minus 40 plus 40 is just 0. The last thing we have to get rid of is the 0.8. So we do the opposite operation. We divide both sides by 0.8. 0.8 divided by 0.8 is 1, leaving us with n. On the right side, number of chocolate bars. 40 divided by 0.8 is 50. Okay? So whether you plug it in and do it algebraically, or you just take a look at your graph and figure out what point has 0 profit, in this case 50 chocolate bars, either way it doesn't matter. Okay, we figure out we need to sell 50 bars. State the domain and range. Remember, the domain and range, you have to refer back to this, okay? And so, well, we'll just use our graph. We'll use our graph to state the domain and range, and according to our graph, you go from an absolute low for the domain of 0, right? That you can't sell less than 0 chocolate bars, to a maximum of 300. It says we have 300 to sell. So our domain is x values such that we have a low of 0 and a high of 300 bars to sell. X is greater than or equal to 0, less than or equal to 300. And again, in this case, because we have a discrete relation, and because 0 can be included, we say x is an element of the set of whole numbers. Okay? For our range, we have y values. And remember, now we're talking about dollars. Now you could go in the hole, right? So if you sold less than 50 chocolate bars, you'd actually lose money. So our smallest profit number is negative 40, which would mean a loss of $40. Our biggest profit is right up here at 200. Y is in between, greater than or equal to negative 40, less than or equal to 200. And because we have negative numbers involved, but we don't have partial values, we would say the smallest number set would be the set of integers. Okay? We're almost there, guys. This one says, use the graph to state the value of p at 150. Now I'm just going to erase this because it's getting messy. Now remember, function notation is a little bit different from a regular equation. When I ask for the value of p at 150, what I'm actually saying is, what does y equal when x equals 150? Okay, remember that value that's plugged in the brackets in your function notation? That's your independent variable or your x variable. So they're saying when x equals 150, what does y equal? They're talking about this point right here where x is 150, y is 80. So, using the graph to state the value of p at 150, we would say p at 150 equals 80, or our profit when we sell 150 bars is $80. Okay? Now G is asking you to do something a little different. First of all, it's saying algebraically determine. That means you got to use the formula. You can't just go to the graph. You can go to the graph to just check to see if you're kind of right, but you've got to use the formula. And the formula is p at n equals 0.8n minus 40. So we'll just write it right here. So p at n equals 0.8 n minus 40. And they're saying the value of p at n. Notice they haven't plugged a number in here. What they're giving you is a y value. Okay? So what they're asking is, what is the value of x if y equals 160? Now remember we talked about this in the previous lesson on domain and range. So we plug in our value for y equals 160. And we isolate n, like we did a little bit earlier. So, to isolate n, the first thing we have to do is add 40 to both sides. That'll give us 200 equals 0.80n. Remember, this becomes 0. And then, as a last step, we have to get n all alone by dividing both sides by 0.80. Okay? 0.80 divided by 0.80 is 1. 200 divided by 0.80 is 120. Okay? And you can check to make sure you did it right. Oh, I did it wrong. How many bars did we have? We had 150 bars. 150 bars is right here. Right. Profit of 160, there we go, is 250 bars. I better get my calculator. Yep, 250 bars. We get there eventually. Okay? So, if you made a profit of 160, which is right here, how many bars would that be? You can interpolate, and that gives you 250 bars. Okay? So that's it for today's lesson. Sorry it went a little longer, but I really think it's important that you understand this. These are really good review questions. They kind of go over everything you've learned in the chapter. So anyways, have fun. See you again sometime.